Hi Ravencoin lovers, welcome to Raven Rebels video about how to create a web app where the user can sign in with their Ravencoin NFT, with their Ravencoin unique asset. So your NFT will be your identity, no password, no username. Your NFT is your identity. Okay, and we will use on the web. Okay, the technology we use is Node.js, and we will use React from Facebook to build the web, React for the web front end, and Node.js for backend logic. And we will, this picture kind of tells us everything. This is how we do stuff. So to the left here you have a Ravencoin, the wallet, Ravencoin Core Qt, the normal Ravencoin wallet. You can have it for Windows or Mac or Linux, and that's the source of truth, right? And then we need some backend logic that communicates with the Ravencoin network, for example, to validate that the NFT exists and which address this NFT belongs to and so on. We write that code in Node.js, so it's server-side JavaScript. To the right here, with the end user, will be using a web app. That web app will be, to create this web app, we will use React.js. We will also use a tool called Snowpack to compile and build everything. And then in the middle, we have a data store, a middleware. And in this case, we use Firebase. So the end user will never, ever talk to your Ravencoin node or your backend logic. That backend logic can be on a laptop, in your bedroom, wherever you want. And that bedroom can be in El Salvador or South Korea or whatever. So that's an important thing to understand. So the web app will talk to Firebase, and the backend stuff will talk to Firebase, but the end user will never talk to our server-side backend logic or our Ravencoin node. So this can be fully behind the firewall. No problem. Okay, let's get started. And here we have an empty directory called Ravencoin NFT sign in, and that will also be the name of the repository over at GitHub on the Raven Rebels. All of this will be open sourced, so we'll be like write once. We will write everything from scratch today. We will create this web app, make everything run, and then publish it to GitHub. So it will be kind of a long video, so you need lots of coffee, and hopefully you will learn stuff. That's like the purpose. It's an educational effort to make people understand how they can build stuff. And to make this, you need to have solid knowledge and competence within web development, and also within like Node.js to write JavaScript code. Otherwise, this will be very difficult for you. But if you might understand a bit or two if you are familiar with Python or other languages. So let's get started. The first thing we do is to create a directory for the client stuff. That will be our web app. That will be like this thing here. So we start with the web app, and it will be simple web app where the user can enter the name of the NFT they want to identify with. And when we have that name, we will backend then check with Ravencoin network which Ravencoin address does this NFT belong to. And then we will ask the user to sign a message with that address. And you sign a message in the Ravencoin Core Qt wallet by, it's a base functionality, right? You click on sign message and you select which address you want to use in your wallet, and you paste in the message that you want to sign, and then you get a signature. So when we have the signature, we know the NFT, we know the address that belongs to, and we ask the end user to sign this message that we give them, something random. If they can do that and they can enter the signature, then we know that they are the owner of this NFT. So it will be a form with like one input for the name of the NFT, one input where they can enter the signature, and if everything is okay, then we know that they are now their NFT. The NFT is their identity. Nice. So let's go to the client stuff. And so now we have an empty folder, so we do npm init to get a default project with default settings. And then we say npm install Snowpack, React, and React DOM. Snowpack is one of many bundlers. There are many tools out there, because you write code and stuff, and then you have something that compiles or transpiles or that shit into a fully functional web app. That's how you do things today. So we have now installed Snowpack, React, and React DOM. And we will use Visual Studio Code as code editor. So on Windows you can use type code and then dot for current directory, and it opens up. So we can say that we have a package with dependencies to React, React DOM, Snowpack, nothing more. Nothing else. So let's create an index.html file. That will be our web page. And then we can go to Snowpack and we go to getting started, scroll down a bit, and they have a template for the HTML page. So we paste that in. And then we check a bit further down, and it says that we should add this line to the scripts part of the package.json. So we do that. We add this to like this. So now we have the command snowpack dev. And we can run npm run start, but start is a special thing, so you can actually do just npm start. It will then open up a web browser, and because it started a web server on 8080. So here we are. This is our web page. And let's start with creating a minimal React application that we append to this HTML document, to the web document object module DOM. So let's do that by creating a index tsx file. That's TypeScript instead of JavaScript, but Snowpack understands that and will fix all the dependencies for TypeScript. So we say import React from React, and we say import React DOM from React DOM, and we get this little app that returns a div with sign in using Ravencoin NFT unique asset. So now we have a very simple React component that will make up our application that just prints out the text. And this doesn't do anything right so far. And then we need to add this one to our page. So we add a div, and we call that div whatever you want. We could call it app. And then we need to say, okay, script source in index.js. And when you use Snowpack, you type JS here because Snowpack will transform the TSX file to a JS file. And the type has to be module. So now Snowpack will import the file. So we should see here in the network tab that it has loaded the index.js. Nice. But you don't see anything on the screen because we don't render this application yet. So we do React DOM render document get element by ID like that. And now it actually should add this one. Why doesn't it add it? Let's check. So it gets our create app to get the name of an app. No warnings. What silly, foolish thing did we do? Okay, the app returns a div. So we render this app and we render it. The document should have something called app. And we do have app. Let's try this one first. Did we do something wrong? In that case, where did we do something wrong? Let's do this. It shouldn't be perhaps that. And now it should be a module. Yeah, it should be module. Okay. Type equals module. Oh, sorry. So what I did was I did a self-closing script. It should be a closing script tag and not self-closing. Okay, so now we have our app. Now let's add some very simple CSS to reset the DOM. So we take away, we say that the body of the document should not have any margins and so on, margins. And we have to import that one. So we say link rel equals style sheet href equals style css. Now we have it, and we can check that it works by setting the background to hot pink. Very ugly. Oh, very ugly. And to make it a little bit more fun, we can always use this little trick, this one-liner that will add 2 colors to the background as a linear gradient. You will see it. So now, looks better. It's a more fun background. And let's say that our app, we start with saying that mean height should be 200 pixels. And we say that background white, so you see it, and then we say max width 400 pixels. Nice. And then we want to center it, so we say margin auto. Like that. And perhaps we want to have some margin, some spacing upwards, so we say margin top equals 40 pixels. Looks better. And now the thing is that we probably want to have some more spacing within this app, so we say padding equals 40 pixels. So now we get some fluffiness inside of it, and perhaps we want to have rounded corners also. Looks better. And to make life easier, we will in this case just use Bootstrap 5, which is like a it used to be really good, but it's just a CSS library. So we get the font is a bit nicer, nice. And possibly we want to in our app say that nice, it's a div, but we should have a heading, and perhaps the heading should say sign in. And this is just and then I think Bootstrap have something like you can say, okay, it's very large. So the size should be a H3 size. Okay, nice. So it's like sign in using Ravencoin NFT. And then we want to have this a field where the user can tell us the name of her NFT. So we want a Bootstrap 5 form. We want an input form. This one looks nice. Let's take that one. And possibly we should have it in steps. Like first you enter the name of your NFT, and then server side we have to check that, okay, which address does this belong to? So let's start with, and we have to close the input thing, and then since we copy pasted this from Bootstrap, in React you can't have attributes called class. It has to be class name, because class is a reserved word. So now it looks better. And the type of this this should be the name of the NFT. We can call this field name. It's type text, and it should be called name, and we don't have a placeholder. So we just say enter name of your NFT. Maybe it's enter the name of your NFT. I don't know English, but and then okay. So here we can type. We have something called rebellious red. I created in Ravencoin Qt wallet. I created a little unique asset, and I used the avatar from our Reddit profile. So we will use this for this demo. We will use friend rebellious red. Okay, so now I can enter rebellious red. That's nice, but I need a button now so I can continue. So here we have a button. So we say button, button, button. So let's just add I don't know what call auto means, but let's take this one instead. Let's place a button under our form, and it's type button. Confirm identity. Nice name. But we should say it like next. So now we can type in the name of the NFT, and we can click next. We have a button to click next. Now we need some state in this app. We need to keep track of the name, right? So in React you do const name set name, and we use the React hook. Use state. And we say that whenever the input field changes, we should have a function that sets the name. Should be like this. So on change, take the target of this event, which is the input field, take the value and set it in set name. And let's just add a printout so we can see that it works. So when we now, we see when we start typing here, we see that it's in our state. So now we can set that value should be name, I guess. Yeah. So now we have that, and then we have the next button. And when we click next, we want to send this one to. So now we want to go from, we entered it here in the web app, it should be sent to Firebase so that we later on have backend code that listens to this shit. So we need a function, we call it next, which will send a request to Firebase. Okay. Let's fake that. Should send name to Firebase. And when we click the button on click, we do next. So rebellious red next should send. That's nice. So now we have the name. I wonder if we can have this class form control on buttons as well. I have no idea, but maybe that will give them the same. Nope, doesn't work. Oh, we would like to have like the same size. It's different sizes, but it's not the end of the world. And I think you can say margin top 2. Yeah. Here we go. We added some margin, so it's some space here. Okay, nice. So the next step will be to talk to Google Firebase. And how do we do that? Well, let's go to Firebase. You go to firebasegoogle.com. Everything we do here is free. So you go to the console and you click a new project and we call it sign in. And then we get a random ID to it. Everyone has projects called sign in. No, we don't want to Google Analytics. And we create the project. Now we create a new Firebase project. Everything on Firebase is done through the web, so you administrate it in your web browser. Very nice. So the step now is just to get the name of that NFT, get it into Firebase so we can start processing it. Okay, we have a new project. Nice. The first thing we do is to create a real-time database. It's the old stuff. They had a Firestore database, the new stuff. I don't know about that, so let's go with what we know. You select where you want the data to be stored. In our case, we want it to be in Belgium. And we can start in locked mode. Now we can start in test mode. That's nice. Because you will define the rules for your data in JSON, so you can say whoever can send or store or retrieve or delete whatever data. So now we have an empty database, and we will talk more about the rules here. But so we have an empty database. That's nice. And now we want to be able to. We want to say that you should be able to authenticate as anonymous. That means that you get some sort of a and you can say, okay, how do you want people to log in? In our case, we want them to be anonymous. So it's like every session gets their own, like a session. That's nice. And then we say product settings, and we say that we create a web app, we call it sign in, and we register this app. We need to get some config to be able to, here we get some nice code that we will add to our project, and it tells us that we have to install Firebase. So let's install Firebase. This might take some time. At the same time, now we can take this default code and we add it to our super long, starting to grow here. This one, our app is just one file. So here we have configuration, nothing fancy. This is totally public. Now we have an application. And we should now be able to use this to store data in Google Firebase. And how do we do that? Well, we say Firebase JavaScript write. I'll go to documentation, and they recently released a new one with, so I have to check all the examples. So we say get database, copy paste. Let's in this next stuff, let's paste in the example code from So what does this do? It's get database, and it creates. Let's start with Elvis. Elvis is always nice. Let's create just a random. It's a NoSQL or not only SQL SQL database, so we can store anything. Let's start with saying that we want to store something called Elvis, and and we want the name to be name. Name should be this thing we have. So if everything works when we do this, then when we click the button, we should update the database with the name. It's kind of fun. Let's check this out. So our real-time database is empty. If we click friend and we click next, let's see if something happened. Nothing happened. Nothing happened. It did not work. Oh, it nags about some. What does it nag about? Somewhere we have class name. Oh, we are not. Oh, sorry, we are not running the development. We were installing the dependencies. We are not running the server. Okay, so we did not get the latest code in the web browser. That's fine. And okay, so now we can once again. Now we have the fresh code, and we click next, and let's see if something happened. Yes, it happened. Now we have sent friend rebellious red to the server. So that's one step closer. Nice. So what does that mean? Okay, we have we want the user to be signed in, so we can differentiate between the different users. So how do we do that? Authenticate user. Anonymous authentication. This is what we want. Woohoo! Let's grab this. So we say we import sign in anonymously. Somewhere here we say get auth. And then we sign in. So, and it's a promise. So when we have signed in, I think we get something here. I think we should get the user object when they have signed in. Yeah, we did. We got something with the user object. So then we can say that I think we can listen to authentication changes. I just listen to authentication changes JavaScript. This seems like kind of nice. Thank you, whoever wrote that code. Hopefully it's like this. What was that? Funny code. Okay. So we say that we listen to changes, and if we have a user logged in, Let's see if that works. And now it complains. 4 should be HTML4. Let's fix that. It's a label HTML4 name. Now I should stop nagging. And we have rebellious red. We click this, it sends it, but I think we should get this. I thought that we would get like a message saying that the user has logged in. Auth state changed. No. Or is this the one? Is this the one? Ah, okay. I should remove the alerts. Never use alerts. It's like, don't do it. But I do it anyway. Shouldn't do it. Okay. So now it's we have this event listener. We can just do sign in. We don't, and then we have an event listener that said, okay, when this happens, store the user. And in React, what we do, we use something a hook called use effect. So React use effect. And here we can have code that should be run at start, and then we tell React the dependencies are, okay, when should it run this? When stuff here changes. So we just an empty array to say, do this just once. And then we can have const user set user equals React use state null. Default is null. So default, we don't have a user, but when we start listening for changes and when the user is logged in to Firebase, we take the user and we tell set user. And right now we could say something like JSON stringify user. So we print out the user. And here we see we have lots of code about the user. But I think it's called, what we want to have is just the user ID. If user and user ID, only print out user ID if user exists. Okay, so now we have a user ID. That means like the ID of the session to Firebase, right? So then we can say that when we have entered the name of our NFT and we want to send this to Google Firebase, of course we don't want to put it under Elvis. We want to have like users dash user.uid. So we should refer to this UID. So now when we set the value, it will be stored under users, and under this is the MD2 at the end here. That's the ID of this current user. And then we can say in the important stuff here is that then in rules we can't say that everyone can write and read everything. No, we don't. What we say is that real-time database Firebase UID rules. We want to see the example of like this. So we can say users okay, let's copy everything. They can only read and write if they can only read and write their own stuff, right? So they can only read and write if they have the same. They cannot read and write other users' stuff. So this says, okay, users under / whatever it is, the ID of the user. If that is the same as the logged on user for Firebase, then it's okay to read and write. So in this case, we can now, when we have pushed the rules, only read and write. Let's change this to red 2 just to see that it's changed. And we can publish. We can delete this Elvis stuff. Okay, so now we have been able to, per user, been able to add the name of the NFT. So the first step from the client side is done, right? Now I have told them who I am. I identify as Rebellious Red from Friend. Now we need, the next step is to listen to changes in this data and have our backend, this guy, the yellow guy, also listen to changes in this middleware and react to it and say that, aha, there is a user. The user have given us a name of an NFT. Let's check on Ravencoin network, which address does this NFT belong to? So let's do that. Let's start with the backend stuff. And sometimes we create a folder called server, but why not call it backend? It's better. Make their backend. cd change directory to backend. npm init default directory. Nice. And now we say that it's called admin. This part of it's called admin, the client that Google Firebase provides us with. So we want to run this code. And to do that, we need to install Firebase admin. Okay, npm install Firebase admin. And in this case, we need a service account. And you get that by going to your project and you go to settings and you take... here we also have some fancy code. Service account. And it says, nice, generate service account. And it should be stored in temp Ravencoin sign in NFT sign in, like that. And now okay, it's one step up. Let's do it like this. Let's open up the parent directory. And this is a shitty name for a file. So we rename that to Firebase service account. So now we have a service account. I will delete this project afterwards, so you don't have to worry about this. And then or we can move this to the backend folder actually. So the index.js, and it tells us that we had two examples, right? We had this example, that was a better example. So path to the service account should be current directory Firebase account. This is the service account. And then we need the right database URL. That's why we should have gone for this guy. Ta-da! So now we have this right service account. And then we look for users. So this is very simple. It says like, okay, head over to Firebase, fetch all the data at users only once, and fetch the value and print out the value. So if we in backend now run this, we see, doo-doo! We got the rebellious red. Nice. And if we don't save once, we can say on. If value changes, it should print out. Okay. So it starts listening. And if we now change something, rebellious blue perhaps, it should be reflected here. Now we have blue. You see, that's so fast. So it's instant. Now we have everything we need here to be able to... the next step now is to take this name, check with the Ravencoin network, which address does this belong to, and then update this node with the address. So let's do this. Function get address by NFT name to Ravencoin. How do we do that? Well, we have lots of sample code over at Raven Rebels where we do this, so we are lazy. We should always be lazy. And we can just go and check for some project, and we have something called get. Oh, so long. Let's take this code and make it easy just for the sake of this. No, we don't. Okay. Get RC. We paste this in. And what does it do? It requires Axios. So let's install Axios. And it says that we should have the username, password, and URL to our local Raven core. I don't know, maybe for this tutorial we can make it even easier. So we can just say... No, we don't. Let's start here. Let's do this. And so we need to have a config. Let's call this Raven config. And we say RPC username or RPC password. RPC. What was the last one? RPC. Was it the URL? Yeah, URL. And then we go to our Raven core and we prepared the wallet with a very phony... okay, so we have the username very, very secret. It's very secret right now for this demo. We normally don't have that, but... And we see that we are running on HTTP. So we should be this HTTP, yeah. And it's 8766, I think, is the default port. So it should be like this, localhost, default port. Yeah, RPC port. You can have whatever port you want. So now we have the info we need. So in this index, we will just import config from require we called it config. We should have called it config.json. And we say Raven config.json. And it's const config equals, and this should also be const. So now we should be able to make a whenever the data changes here, we say RPC equals get RPC, and we send in config. This is kind of like no, we shouldn't. To make you guys understand this, I think it's better that we drop this stuff. We add it here. And we say, we just get a function, call it RPC. And we say that we should send in, we call it config, and method, and params, because you want to send in. This is how we do it. So we should say, now we just have the code that like, now it's just pure Axios. It's just a function where you specify options for Axios, which is that, or this is how you authenticate with the Ravencoin RPC HTTP stuff. The data we send to Ravencoin is just keep this one at 1. This can be in whatever ID you want to call it. And the method and params. And what is that? Well, you go to, if you open up the wallet and you go to debug and you type in like help, you can see all the stuff that you can do, right? And this is the, so in our case, we should get like the address for asset, whatever is that called. List addresses by asset. Let's test this on. Friend rebellious red. And it gives us the address. Very nice. And if you type help list addresses by asset, it will tell us that how you should do this. So the arguments could be asset name, and we get the address back. Okay, that's why we get address and 1, because it's a single, it's a unique, so it's only 1. But anyway, so this is what we do. We want to send list addresses by asset and no other empty params. And then we should return RPC response. Delete all of this. Delete. Now we have a very simple RPC function. So it's like, okay, Axios, go to this guy, return this one. So in this case, we say list addresses by asset, and the params should then be name. Maybe we should be fancy pantsy and say, okay, this is the arguments. We can add that to the code to make it more clear. It's good to be lazy, but you should never be lazy when it comes to documentation. So we understand that the first argument should be the name, and that is why, and name doesn't exist yet, because we get that from, we have to parse that out from the snapshot, right? So we know that we are, from the database we get users have a user ID, and every user ID has a name. So it's like constant data equals snapshot value, and then we should say, so we understand that the let's just log out the data. So whenever things, whenever we get data, we get, okay, we get something where we know that the key is the user ID, and then the value is the stuff we need. So we say const users equal object dot keys from data. So we have user keys or user IDs. But it's called key in Firebase. And keys. And then we can map over those user keys for const user key of user keys console.log user key. Now we should print out every that's the ID of our user. That's the ID here. Okay, good. And now we say const user data equals data, and we get it by user key. So then we can say user key has this data. Okay, and remove that console log. So we say, yeah, nice. So the name here is that. So when this is done, for each of these, we want to check the address. And we're starting to get some code here in this. Let's copy this one. Let's call this just listener. And it's a async function snapshot. Let's add this to a let's declare a function, and let's declare a function that is async, so we can use a wait. So we say, okay, here we got some data from Firebase. Nice. Let's parse out the user IDs. Let's parse the data per user. Let's talk to, let's console.log. I want to see whatever we got. So let's ask for the users by name, and we do this per user. And what is name? Well, name should be user data dot name. Let's see what we get when we do that. Axios is not defined. Of course not. Now it should not complain. Oh! So we saw that it's probably response.data might be what we are. Okay, so when we send in rebellious blue, which does not exist, then we get something back with the result is empty. So dot result is the value that we get back. And it's empty. Of course it's empty, because it doesn't exist. So let's, if we now change this to rebellious red, this code should run, and it should find an address like that. And now it was red. Here we go. Now we got the address. So we can say let's say response.data.result. Okay. If Raven data.address. What was it called? Add. Okay, so it is an object which contains keys, and the key, the first key, should be if object dot keys if this is 1, it should be because they might actually give us the name of something. Let's say that they didn't take something that was unique. They took friend, which has multiple addresses. No, it does not. Friend centralization has multiple addresses. Oof, there we go. Then we get many addresses. Because, okay, so they might not. They might type in the name of an asset with multiple addresses. So this code should only work if they should have one and only one address. Otherwise, something is wrong. And address should be object.keys raven data 1, like the first one, right? This should be the address. So what we want to do now is update the object in Firebase. So we want to say database ref plus user key address should be so when we get only one back and the key should be the address, then we should update the data with the address, right? So if we run this again, if we don't fuck shit up, or what was that? Response. Okay, so now it should have updated the database. So let's check the database. It did not update the database. Why didn't it do that? Let's console log the keys we get when we ask for that. The shit. What did I do wrong? This what was this? Rebellious, not a valid asset name. Okay, we got text back because it's so we got an error. That was strange, huh? Okay, that's because it's not called rebellious red. It's called should be like this. Rebellious. Let's do this. Now we update database. Now it works. Now we updated to friend rebellious 1, and we saw that there is only one. When we asked for the addresses that this guy is with his name, only if it's only one unique hit, then we update the address, right? So that's nice. Now on the client side, we would like to say when you click next here, we would like to say that, okay, nice. We want you to use the address to sign a message. So let's inform the user which the value of, we need to send this address here to the poor user. Okay. How do we do that? Well, we go to client and we say that at start it should, whenever it is starting to, when we have a user, we set the user, and then we can also start listening to changes, right? Start listening to changes in Firebase. So we have a reference to the database and its users, blah blah blah, and we say on Firebase JavaScript read, because they have changed the API, so it feels like backwards, but write data, read data. Here we go. Oh, we need to have on value from database. So we go to database and we say on value, and then here we say on value. I guess we send in the reference and then the function. Okay. So this is the reference. And now we have what we should, the function telling us what should we do when we get data. So let's console dir, this one. Whenever it changes, okay, like that. Whenever this one updates, we need the data on the client side. So here we are. And we can, for example, let's delete it. And let's create it again. Oh, we are not running the start. Blah, 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 blah. What are you complaining about? From. Okay. So now we updated the database. So now it has rebellious Raven, and we are not running the backend. So now we're running, and then we assign the address, and then now the client should know that. So the client has, oh nice, we got the snapshot. So here we say const data equals snapshot.value. If no value exists, if not data, just return. It can be null. But if we have data, we want to update stuff. So let's say, let's create a new state here with const address set address react use state. And if we have data, then we can do set address to data.address, right? So we set our state to the address we got from the server, and we can say that we have user ID. This is just to make it easier for us to address. Easier for us to what? Easier for us to develop and receive the state. Nice. Okay, so now we know that we do have. This is the name of the address that we want the user to use when they log in. Let's change this. It was so humongously big. And server side also, when we are server side, we have the name of the asset and we want the address, but they can change the name, right? So if the data does not if they have the name, we want to make sure that they have an address. But if we did not, they might have done this once and got one address, and then they change. Like in our case, if we change to this one. Yeah, nice, the address is gone. So what if we write friend centralization that we now have multiple? We know that it's because you don't want them to get one address because they add one name and then they change the name and they keep the address. It should be out. So this seems to work. So then everybody's red. Now we have the address. And what we now want to do is we want to create a message that we want them to sign. So let's do this. You should not use math.random is not safe, but we use it now. It's kind of safe, but so we say let's update not specifically the address, but let's update the user. Update will just append whatever you send to it. It will not delete stuff. So when we update the user object, even though we only send in address and message, it does not remove the name because it has address, name, message. So okay. And in our client, let's go to the client side. So this is the next button. If address and can remove this one. This address. So then we say please sign the message with the address. Kind of strange, but you get the point. And then we say address let's add a blank. And message. We also need to have message. Holy crap, something is updated constantly. Let's stop updating constantly. So it was the server running crazy. Of course it was, because what do? We change it and then so we have the name and we check the address. And if the address is the same as we already had, then we shouldn't update the database. If address not equals user data.address, only if they have changed address, we should do this. Otherwise we update all the time. So now they have this address. So now the client, we go back to the client, we should say, please sign the message with address. Okay, this is the address. Now we should print out the message as well. And where do we get the message? Well, we have to refactor the code it, so lots of stuff in one place. Never do that. Okay, let's start. We say data.address is address, set message equals data.message. And now we say, okay, with this address, sign this message. In our case, that would be sign message with this address, sign this message, sign message, and now we need a input field here where we can enter the signature. So we need a text box. Nice signature. And we add yet another const signature set signature React use state empty. So it should be the address, the message, and the signature. And now we have the signature here. So we say and when we have the address and the message, we should not. What happens if we change this one to rebellious blue? Nice. Okay, so then it's good. That's good. Change to red, and we got a new message. But does it, when we change to blue in the database now? Oh, that's good. It's because the client is setting it. But anyway, so this is nice. Red, please send a message. So if address exists, we should not show this one. So we can say not address and from here to there. No. What the fuck? This one goes to, this is the input. Oh. So this one goes to, it's and then from that one to that one. So we only want to show this part if address exists. So let's get a new div. So like that. This is the user ID. We absolutely do not need that anymore. Remove that. This is the using. Please sign the message with the address. We can make this an H5, no 5. So you should type in the signature. And when you have done that, so when you do that, and you click sign in, then we should let's do function sign in, and then we say on click sign in, and it should be like we do this const sign in equals arrow function. And this is what if signature, when we change the value of this text area, we should update the signature, right? On change equals so if signature exists, then we do update, we do set and signature, and then we should wait. I don't like the set will like the problem with set is that it will overwrite. It's like reset, so it overrides everything. So it's good to have it when you set the next when you set a new name of a NFT, because then you reset your object. So you will remove address, you will remove signature, you will remove message. But in this case, we want to update and say that signature equals signature. So in this case, we say, okay, let's use this address to sign this message. And now we have a signature, and we add this signature, and we say sign in. And now we have the signature here. So now the server-side code should now verify it. So we should say that, okay, we listen to all the user objects, we make sure that we check that the user we have updated the address, with the message, and we should also say if user data dot address exists, and also user data dot signature, check with Ravencoin if signature is correct. So now they have message. When we have message, address, and signature, we can just check with Ravencoin if that is okay. So let's check what that's all about. Perhaps it's called something like verify message, help verify message, and it says Verify sign message. Address, signature, message. Doo-doo! All we need. What the Okay, so let's check. So then we call await RPC and config, and then say verify message, and we send in an array with user data dot address. We send in user data dot signature and user data dot message. And what do we get back? Let's print that. Result true. Nice. So now we know that we are, because we saw this earlier, that we're looking for it's true. And when this is true, then we can say, let's just set the flag on the user object. When this is true, what we can do is we can create a new selection where the user can only read but not write. So we say this here, const to save equals address. It's user data, but anyway, user data dot address, signature, user data dot signature. Message equals user data dot message. And we can say is verified equals object.data.result. And now we save this to another place in Firebase where the user cannot update content. They can only for lack of better names, verifications by user ID. So now it's like verifications by user ID, we call it, and now we create a new object with the user key. So then we have to, in our rules, say that, okay, the users can read user, but they can also read they can't write, but they can read if they have the same user ID as this one. So when this happens, let's run this code and see what happens. Of course not. Okay, that was not so. What was this? It's like the end of the world or something. Did we miss something in the code? My lord. What did we do? Okay, if we don't do this, then everything runs fine. But if we try to, oh, maybe this one is, okay, let's do this. Okay. So address is not supposed to be so if we have address, signature and user data, address, I'm getting tired. I'm starting to paste it in the wrong place. So, okay. Here we go. Now we save that to the database, and we can say that now this user has a, we can say that we should also store the name of the NFT, right? We must store the name. So that it's obvious that we stored it with this name. And then we can always check that this address with this. And later on we can also check, because perhaps you want to check that the NFT has not moved, so that the user cannot log into your site, be logged in for days, but they have transferred the asset. Anyway, now we know that it's verified is true, and so now we can have a on the client side. What we should do is at start we when we start this application, we start listening to, and we all have logged in. Then we set up this listener that listens for user, right? We should do the same thing for verification by user ID. And when this changes, we are only interested in if the data is verified. So let's add the last thing, is verified. Set is verified. Oh, bad word, but anyway. Start with false. Set is verified. Should be Datadog is verified. Right? And then we can print out, now we print out the name, and we print out a message, and we can say if is verified, now we can do like if user is verified, okay, now we have to reload. Okay, so it says, okay, let's take this address and verify the message. This is the address. This is the message. We were sign message. Sorry. Now we have the message. So now we have the address and the message, and we add the signature. We click on verify message, and it is true, it is verified. But the question is if our okay, the value is verified. I have verified it. So why don't we get this very, very nice value if is verified and or is it the text true? Sometimes it's you think it's a boolean, but it's not. It's a like that. If not is verified and you are verified. Hello. Because in this case we can store the whole object. Const verification object set verification object so set verification object data. And then we can use, so then we can say, hello, where's the name? So we set the verification object. You are verified. Hello, friend Rebellious Red. So now we are logged in as Rebellious Red. That's not bad. That is not bad. So let's try this from the very beginning. Let's delete all the data. And we log on and we say sign in using Ravencoin NFT unique. Enter the name and we say we are friend Rebellious Red. Next. Oh, I didn't have a... Let's start again from scratch when we have the server running. Sorry for that, guys. Let's have the backend running. And okay, we have a problem if it's... not to worry. If data... If not data... So the data will be null if there's nothing in the database, of course. So, of course it's null. So here we go. Please enter the name. We enter Rebellious Red. We press next. Please sign the message with the address. And so we take this address. And we take the message. And we sign the message. We enter the signature. And we are signed in. Now we for sure know that this user is verified as friend Rebellious Red. And now my NFT is my identity. No more username, no more password. Just access to NFT. In the future, hopefully, all the mobile phone wallets will support signing messages in a very slick way. But this is just the start of something new. We are early. So this is really, really cool. And to not make this tutorial too long, it's good if you have watched it all. I will clean up this code. It's kind of messy, but it's a hackathon style code. So let's fix this code before I publish it to GitHub. And you will find this code on GitHub Raven Rebels under Ravencoin NFT sign in. So this is where you have it. If you like this video and if you want to have more things like this, please give it a like, drop a comment and subscribe and share it. And if you have any kinds of, if there's anything else you want to see, please drop a comment. It's always nice. So thank you very much for your patience. Bye.